terminology or applications are different. So we are going to see how much energy is released by combustion reaction. We know that what is combustion. Combustion is uncontrolled oxidation, right? Sorry, or burning. Say for example, if you are burning propane gas at home, C3H8 plus oxygen, it will form carbon dioxide and water. Let me balance this. So this equation, we know that it is releasing heat when you burn something. Okay, so there is heat is also released. That heat is called heat of combustion. So we are going to do a calorimetry experiment. Say for example, to make you understand. So you know that when you eat something, you are getting calories, you are getting energies, you are getting joules. So this is a method we can use for calculating it. We usually do that kind of lab like burning some food like easy chips, or you can do Cheetos or something like that in a calorimeter and see how much energy is releasing and how much energy is in changing the temperature of water, something like that. So it's kind of same concept. So we are going to calculate. So you have a calorimeter which has a mass of 25 and which has we added water. The total mass of calorimeter and water is 100 gram. So find the difference. So the mass of water will be 100 minus 25, which is 75 gram, right? Okay, then initial temperature of the water is Ti, that is this, and final temperature of both of the water and uh, the final temperature is actually it is there is no metal here. Okay, so final temperature of the water is 36 degrees Celsius. So the questions are asking you burn the food in a calorimeter and that heat released is used for raising the temperature of water from this to this. Okay, so we are going to see how much heat will be produced by that fuel or whatever food you burned. Okay, or how much heat is gained by the water. It's easy. So I'm going to calculate the Q gained by the water will be equal to mass of water, which is 75.0 gram, and we know the specific heat capacity of water, which is 4.18 joule per gram degree Celsius, times for change in temperature, which is 36 minus 25. Okay, 36.0 minus 22.5 will be 5 3. Okay, uh, 3.5 degrees Celsius. Okay, now get to the calculator and you have to sorry, you have to calculate. You will get 4,230 joules. That much heat is gained by the water. So how much, what is the heat of combustion, or how much heat is produced during combustion? So we are using a different wording, that's it. So heat of combustion, Q of combustion, you can write like that. Q of combustion is equal to negative what? Negative of this negative is 4,230 joules. And it is asking in kilojoules, then you have to convert that into kilojoule by dividing with 1,000. So that will be negative 4.23 kJ. Okay, that is that. If 1 mole of food was burned in the reaction, calculate the heat of combustion in kilojoule per mole. It's just writing Q of combustion. Okay, so we know that per mole, so you just divide with the 1. Okay, so you will get 4.23 kJ divided by 1 mole, which is equal to 4.23 kJ per mole. That is the heat of combustion in kilojoule per mole. Okay, so Next question, it says a sample of coal. You know what is coal is, okay? Heated in, burned in a calorimeter with 150 gram of water. Temperature goes up. What is the heat of combustion? In joules for burning coal. Heat lost by the coal, okay? Okay. So same thing, we calculate the heat gained by the water, which is mass of water 150.0 gram times C of water, which is 4.18 joule per gram degree Celsius. Then the change in temperature will be 115 minus 25 degrees Celsius, right? Then you calculate, you will get negative 564 uh, 00 joules. Okay, so it's not negative, it's positive. Okay, so then q of combustion, okay, q of combustion is equal to negative 56 564 joules. Okay, so now the question asking, initially the mass is given 15 gram of the coal was burned. What is the heat will produce if there is only 1 gram? 1 gram joule per gram means there is 1 gram. Okay, so basically what you are going to do, this is 15 gram. Okay, 15 gram produced this much. Then 1 gram will be, you just divide 56,400 joules negative divided by what? 15.0. That's it. It's 15.0 gram. So you will get negative 5,760 joule per gram. You check the calculation. Okay, so that's heat of combustion, basically the same thing, but the concept is little different. Okay, so this is the end of the first part of the thermodynamics. You will have AOL number 17 till here. Okay, enthalpy and thermochemical, all of this will be for your next AOL. So finish study all of this, do all the practice and watch the review and study. That's it.